So thanks for this opportunity once again. I'll present our problem statement, which is the automated system for noise barrier installation on MRT viaducts. So the photograph that you see here is a project which is currently in progress on the Jurong regional line. And these are what we call as vertical noise barriers and cantilever noise barriers. So the structures in this photograph does not have the panels installed. So the challenge statement is to install the panels using an automated system, which I'll cover in the next couple of slides. I think you can skip this. So currently on the MRT viaducts, we are doing a manual system. The panels are installed manually, where workers operate from on boom lifts, on locomotives and wagons. It's a high-risk environment, working at heights, working in the open environment. Fatigue sets in after a while. Repeated lifting of panels means that workers get tired after a while. And so we have multiple challenges on the current operations, which is really a very manual operation. Next. So this slide will give you an idea of what happens. This is the way it's currently being done. We have a boom lift. A boom lift brings up panels from the bottom on the platforms and then brings it up on top. And two guys on the boom lift actually manually push the panels all the way from one end of the cantilever all the way to the bottom, which is what we are doing. Next. So what we are exploring is something like a conveyor system we have a system on top installed all structures. Anchor points might position the panel.
I'm sorry to interrupt, Vijay, but there was a bit of a disturbance in between. I think there was a connection problem. Could you just repeat your last sentence?
I said the problem statement that we're exploring, the challenge statement is all explained in this slide. So I hope whoever is here pays particular attention to this slide. So if you see the arrows, can you see the arrows moving? Yeah, that's how we intend to do the automated system, where we have a conveyor belt placed on top of the structures, and then the system itself takes care of the panel, pushing it from one end all the way to the bottom. So I'll do this again. Can you redo that? So the green arrows is the one which actually moves the panels. If you pay attention, that's how it does. It pushes all the way to the horizontal side and then all the way down to the vertical side. And this operation happens on every bay. So you can see multiple bays of structures there. So we are looking for a, we thought it's a conveyor system, but we are open to other suggestions. Next. High fall risk working at height. Low productivity, which I explained earlier. Inconsistency and high manpower demand and operational efficiency. I think these are all known. So in the challenge statement, we need to address productivity improvements. So I would prefer to have just one or two guys operating the system remotely. Obviously, it should meet all of MOM's and LTA's requirements. There's potential for modular growth in this operation because the Jurong regional line is one project which is just started. Then Cross Island line is coming up, and then I'm told there are many other projects on the roads also. If we have an automated system, it should help to address the labor shortages, and we look at something which is automated in construction 4.0. Okay, I have some functional requirements here. We should be able to operate in tight spaces between the parapet and the railway track. Consistent installation quality is absolutely a must because it's a controlled environment. It is repeatable. We have just given this, and obviously manpower need should be reduced by greater than 50%. Thanks. Okay, these are the remaining technical requirements. Panels itself are very lightweight, so a track-mounted structure on the existing viaduct should be able to handle that. The sizes of the panel is roughly about 2 meters by 500 wide, and it weighs about 18 kgs. The system must be automated, and with some sensors positioning, you should be able to get the alignment in place. Fastening systems on the structures itself should be also automated in order to get the panels in position. And the rest of it is obstacle detection. If there's something on the way, you should have some path planning in order to have a continuous workflow. Okay, we would prefer a remote controlled operation, so we don't want people going up, just standing on the platform. It should be quiet, should be fast, it's modular. What we offer is we can do installations under the live site conditions. So it's on the existing tracks. We have simulated existing track environment. So we offer that. We can actually test it on these environments. We call it test transfers of cantilever structures, which is just the joints of the structures. We can explain that in details if people ask more questions on that. The panel itself is it's lightweight. We have to handle the whole panel by some sort of arms, and the alignment and anchoring should all be automated. Essentially, what I'm saying is we don't want to have any manual handling of these automated installations. Next. Okay, we will provide the designs. We will provide access to the site. We have done this previously with the robotic arm, so we are familiar with integration and test support. And we will have our technical team, to provide the safety reviews and necessary feedback. What we offer is also an opportunity to deploy in existing current project and upcoming projects. And the potential applications we see is beyond the MRT viaducts. Probably we can apply it for facades, for solar panels, and other systems. Yeah, thanks. And that's the end of my presentation, and I can take questions now.
All right, Vijay, thank you very much. That was short and crisp. For the participants in the room, if any one of you has a question, we now open the floor. You can add your question to the chat box, and I will help raise them to Vijay. While we wait for questions to come in, Vijay, I had a couple of questions as well. So you mentioned that you are looking for a remote controlled solution, but are you also open to having a semi-automated solution that doesn't quite replace manpower altogether, but sort of has an in-between execution?
Certainly, we can look at it. As long as there are productive improvements and it's safe, we can look at different options.
All right. And how are you envisioning these solutions in terms of adaptability to future rail lines?
We will have to incorporate these into the design. So it's a DFMA. So we start with right at tender stage for future projects. For current projects, we have to look at the structure which is already there and how do we implement it. So either it's on existing project or on structures not installed, we'll have to probably modify it according to what the systems come about. So I'm open to discussions.
All right. Also, finally, I'm sure you've already done a lot of research in terms of other solutions that are already out there for this particular problem. Is there something that you are categorically not looking for?
Not really. We've explored quite a bit. We did not find anything which is similar. One of the biggest challenges for the operator, which is either the SMRT or the other operators, is they have a very tight timeline to replace these panels subsequently, 5 years or 10 years down the line. And so a system like this would perhaps help them more than it helps me. I don't have restriction in terms of time now because the track is not operational. But in future, there's more potential. And that's the reason why we thought that this can help with operation and maintenance as well.